Okay, in this gas laws lab, we're going to explore the properties of gas and we're going to take a gas air through different changes, and we're going to see the relationships between pressure and volume and temperature and the number of particles. So it's a three-part lab. Part one, pressure versus volume. So what we're going to do is we're going to control the volume. That's going to be our independent variable. And we're going to record the pressure. So we're going to wind up with a graph where, and we're going to show the relationship between the pressure and the volume of a gas. To do that, we need to keep the number of particles constant and the temperature constant. So we're going to use the LabQuest. And the LabQuest, these are kind of old, and so the batteries are shot. So you need to plug in uh, the power supply into the thing to get it going. Here's your on-off switch right up here. It's got a blue glow around it. Sometimes you kind of have to push it and hold it in to get it going. These are, they're hardy, but they're getting a little bit old. And then so turn it on, and it sometimes takes a little while to come on, but be patient. With no sensors in, it's just kind of a blank screen. But as soon as you plug a sensor in, so we're going to be using this one. Now in your box, the little box, there's a gas pressure sensor. We talked in the last video about you could use a barometer to measure atmospheric pressure, but we use electronics now to measure pressure. There's a little syringe, and then there's this stuff that is going to be used in part 3. For right now, all we need is the syringe and the gas pressure sensor and your LabQuest. Now, when you plug the gas pressure sensor into one of the ports in the back, it should come up giving you a reading, and it'll probably come up in kPa, that's kilopascals. We don't want to use that one. You can take like a fingernail or a pencil if you touch gently. Click on the units, hit change units. So it's just touch screen, right? So I touched on the kPa with my fingernail, hit change units, go to ATM. And I'm up here in the mountains today, so it says 0.828 atmospheres pressure. So it's a little bit lower because I'm up at altitude. In Monrovia, it should be just under an atmosphere, like 0.98, 0.99, 0.97, something like that. The actual absolute value doesn't matter as much as we're looking at the changes in pressure. So that means everything's working good. If you get some weird kind of reading, just move it from one port to another and see if it's working. We did check these out before you picked them up, so hopefully everything works. Now, what we're going to do is the gas that we're going to test is the gas in the syringe. We're going to start at 10 milliliters equals volume. That's going to be our starting volume. Now I'm going to take that. So by 10 milliliters, when you say, well, wait a minute, where is 10? What you do is, I don't know how well it'll show on that video, but you have the front of the black rubber stopper in there, the front line of that black rubber stopper at the 10, right? And so that's it, because I'm looking at the volume from the front of it to here. So that's 10 milliliters. Take this, and it's just a little twist connector. Twist it on to the gas pressure. Don't over tighten, you'll break it. Just a easy finger tight, not too tight, but tight enough that there's a seal. And so now it's connected. So there's my starting volume. I now have, a contained gas, contained 10 milliliters of air. So you're going to do and try, squeeze it down, go from 2 milliliters, 5 milliliters. You can come back to 10 again. We already have 10. 15 milliliters and 20 milliliters. So we're going to look at and read the pressure at 5 different volumes. So what I do is I take this thing and I squeeze it down to 2. It's going to fight you a little bit. You have to push and fight and get it down to 2. Hold it steady. And mine says about 2.3 atmospheres or a little more. So hold it steady, and then read the pressure. So your 2 milliliters, what's your pressure? Don't go beyond 2. I put that warning in the instructions. You can say, well, how strong am I really trying? But you can break it. The pressure really shoots up high. Don't break this, so don't go past 2. If you want to prove how strong you are, squeeze a tennis ball or something like that. So don't test on this because it will break. So you get it at 2, then bring it to 5. Hold it at 5. Hold it steady at 5, a volume of 5. Read your pressure again. Bring it back to 10. Read your pressure. It should be the same as it started. Bring it out to 15. Read pressure. And then bring it out to 20 and read pressure. So that's our data points. And then after, of course, in the instructions, we'll be graphing this. So that's part 1, pressure versus volume. Part 2 is going to be really very similar. Part 3 is the different one. Part 2, pressure versus, and I'm going to abbreviate number of particles, N. You'll see later N is going to be moles. So pressure versus the number of particles. We're going to change the number of particles. Because I'm changing the number of particles, that's my independent variable. I need to keep the volume, when I'm reading it, the volume now has to be constant. So volume equals 10 milliliters constant. Now, what we're going to do to change the particles, of course, how can I change the particles? It's a sealed chamber. What I do is I'm going to disconnect it every time. To start out, I want to start with a starting volume at 2 with it open. So now, before I kept it connected while I changed my volume. Now, every time I'm going to open it to the air so that what happens, so as I can see, when I start with a really big volume, there's a whole bunch of particles in there. When I push it down to a small volume, I've squeezed fewer number of particles. So we're going to control the particles by controlling the volume it's at when we connect it to the gas pressure. Twist it to connect it again. So I'm at 2 to start. And what I do is I'm going to pull it back to 10. And, I'm having to hold it there. It's fighting me a little bit, right? So it's at 2 when I connected it, and I bring it back to 10. So we said 10 milliliters is the constant volume. That means every time, regardless of where I start when I connect it, when I'm reading pressure, I'm always holding it at a volume of 10. Okay, there's the first one. I disconnect. I bring it to 5. And I connect. So now there's a little bit more particles, and I hold it, and I bring it back to 10. Read my pressure. Disconnect. Bring it to 10. Connect again. And of course now it's at 10, so I'm just going to hold it at 10. Read the pressure. Disconnect. Make my starting volume 15. Connect. Push it in. Hold the pressure. Hold the volume at 10. And then read the pressure. So my starting volume is 15. Now I'm squeezing in that amount of air down to 10. Last one. Disconnect. Hold it at 20. And then squeeze this thing back down. And then hold it at 10. So that's all my data for part 2. So what we get, and what I put in the grid for you guys to record, so you have a starting volume. And that's going to be 2, 5, 10, 15, 20. My constant volume, measuring volume, is 10 each time, right? And then pressure. And then you're recording your pressure, right? So that's how we'll record our data from this one too. Those two, once you got it, boy, they go really fast. Now, part 3. So what that says is, so what this one is testing, hey, as I increase the number of particles, right? I started with just a small starting volume. As I increase and add more particles into my chamber, and I got more particles bouncing around, what happens to the pressure? Now, pressure versus temperature. Okay, now you have in your kit a 400 milliliter beaker. Remember, 400 milliliter beaker, the markings usually only go up to about 300, but and then the last is not marked, so it's called a 400 milliliter beaker. And I put it about half full of water, around half. Now, what we're going to do is, so it's pressure versus temperature. We're going to change the temperature of the air. Now we're no longer using the syringe. We have some air in our 125 milliliter flask, and I connect this white rubber stopper. It should be connected just like this. There's this tubing here. So one here, make sure everything's tight. If you have any leaks, you'll know that you have a leak because you'll do this and you'll change the temperature. And if your pressure stays constant, you've got a leak, right? So if you've got a leak, then the air can run in and out to keep the pressure constant. Okay, so I connect one end like this, and so I'm just showing this. Notice this valve must be perpendicular to have it sealed. If it's like this for all gas valves, if it's parallel, it's open. Close that thing, perpendicular, and then good seal. This is a good seal. Now instead of plugging the syringe in, the other end of this tube plugged into the gas pressure. Again, just finger tight, but make sure it's tight. This should be completely airtight here, because if I have a leak, and you'll know it if you have a leak, and you'll say, well, why is the pressure not changing? You have a leak. Now, take the water in here. So don't put the beaker directly on a stove or anything like that. If you have a microwave, microwave the water to get it hot. It doesn't need to be boiling, like 80 degrees is fine. Now, in this case, we're going to have two things. By 80 degrees, I mean 80 degrees centigrade, of course. We don't use Fahrenheit in this class. You have this temperature probe. You're going to have two different things plugged into the back of your LabQuest. And when you do, let me get this to where it can show, you'll have two different readings. So it's reading pressure in atmospheres now, because I've got the gas pressure connected. And it's reading temperature in degrees C. It got to be in degrees C. And right now mine's saying about 20.8, so that's about right. Your temperature should be, in the low 20s. If there's something wrong, I checked out all these temperature probes before we passed them out. If there's something wrong, try moving the temperature probe to a different port in the back of your LabQuest. Okay, we're ready to go. So I'm going to take this. I want to start with hot water, around 80 degrees C. So my temperature, I don't have a temperature probe that can make it into the actual chamber that has the air. Unwind. But I can put the temperature probe and measure the temperature of the water. Of course, don't put the temperature probe in a stove or in the microwave. But after, just check it. What's the temperature? So what I can do is I'm going to heat my water either in a pot on a stove and then pour it in here, or heat this thing in the microwave. Don't put the beaker on a stove. Okay. Now let's assume I got hot water in here. How am I going to change the temperature of the air in my flask? I'm going to submerge the flask in the beaker. It's going to want to float. You'll have to hold it down. By having the water about halfway full, the water now pretty well covers that. If I hold this in there, and while I'm holding it in there with the hot water, you'll see the temperature reading, of course, will climb, but also you'll see the pressure start to climb. Within about a minute, it'll hold pretty steady. Now, what we won't see in here is we won't see huge changes in pressure, but you should see the pressure start to climb. If it doesn't climb, what happens? You have a leak. So you'll see the pressure climb. When it levels off, okay, what does that mean? That means the temperature of the air has equalized with the temperature of the water. So I'm reading the temperature of the water, but if I wait for that minute till the pressure equalizes, the pressure of the air inside the flask is equal to the temperature of the water. So record that new pressure at a hot temperature. Then what I'm going to do is I'm going to take this out. Now I want warm water. How can I get warm water? I could pour half of this out, half of the hot water out, and replace it with just water out of the tap, room temp. Do the same thing. Record or wait, hold it in there for a minute, let the pressure get constant, record the temperature and the pressure as soon as the pressure gets constant. Now I want room temp. What do? Dump all my warm water out and replace it with water just out of the tap. Same thing. Now I want 2 more data points. So we got temperature we got hot temperature, we have warm, we have room temperature. I want cool. How do I make it cool? Just a couple ice cubes in there, a little bit of ice and some water. Get it down to about 10-ish degrees C. The actual doesn't matter. I got cool water. And then I want down as close to 0 as I can get. How can I get to 0 or close? You want, especially it's better if you take your ice cubes and kind of crush them up, some crushed ice. You want about a 50-50 mix of ice and water. Gets you down pretty close to 0. And that's your last point. Now, once you have all that data, move this stuff. So what we got is a data point. So you got hot, warm, room temp, I'm going to just put RT, cool, and cold. These should be, so hot should be somewhere around 80 degrees. Record your actual temperature. So you're going to record, let's say it was 77.1. Record your temperature. Record your actual temperatures in here. And the pressure. We should see the pressure vary, but not as much as it did before, because as we'll see, we're comparing the pressure to the Celsius temperature in actual, we're going to convert that into absolute temperature or Kelvin temperature later. But you should see this change. If it doesn't work or you're not sure about your data, what do you do if you're I'm not sure about the data? Repeat the lab. It won't take that long. Just do it again and compare those 2 trials. And then from there, we're going to graph this and we're going to develop a model that explains what we observed in this lab, what at the particle level, what's going on when we change the volume and why do we see what we see. And so that will be the next part and how we expand from this lab. To give us an understanding, again, this is in this unit, it's all about energy. What are we doing? We're looking at the energy of motion of the particles and look at how they're bouncing around and see the result for that model of matter. Enjoy the lab.